Hello everyone, in this video I'll show you how to set up, maintain and monitor a microservice architecture with Spring Framework. I'm going to show you the basic in this video, but you can definitely expand from here and make it as large as you need. To demonstrate the microservice architecture, let's assume we are building an e-commerce platform. Initially we have one microservice, book service. It can give you information like list of books or detail about an individual book. Now let's expand a bit. We need another microservice named order service, which is needed to order those books. Now let's assume there is a lot of traffic coming to our book service, and we need to increase the number of book service instances to fill the demand. So we add two more book service instances to meet the demand. Now we can have a couple of problems here. Firstly, how to keep track of all the instances where these book services are available, their IPs and everything. From an end user perspective, which book service they are going to connect, how to identify among these book services instances which one is in low load. We want the end user to go to a low load instance of book service so that they can better performance from our e-commerce platform. Finally, if we need to change some configuration, for example book discount or running port, or how to avoid duplication of configuration to all these available services. To handle the above problem, we can use the following technologies. We'll use a configuration server where all the configuration can be stored in a single place. We'll use a discovery server. It will keep track of all the running instances. We'll use API gateway, which will load balance between available instances and return result from a low load and highly available instance of book service. Okay, let's say we have set up the microservices. Now, how do we make sure all the microservices are running properly? Let's say we have a book service to show books, order service to show order of those books, payment service to handle payment, and delivery service to handle delivery of the product to the customer. Now, how can we keep track of all these services? And if they are not running properly, how the system manager will get notified properly via an email, or how he can see it on their screen via a graph. To facilitate this, we will be using following technologies. We'll be using distributed tracing with Zipkin and Sleuth. We'll use Actuator and Prometheus to collect system metrics. We will use Grafana to view those metrics in a nice graph and show alert or send mail if there is any problem with our system. Before setting up the system, I would like to let you know, as mentioned initially, I will build the system with the Spring Framework, more specifically with Spring Cloud. I will not write a lot of code, however. I will show you mostly the basic and show you how you can expand from here. I'll write the code with Kotlin, but you can easily do the same with Java or other language. The code will be pretty same. I will not use any databases. You can use any database you like. I have other video in my channel where you can see how to connect to different databases. And finally, I will not be adding any security, because it depends on how you want to implement security in your system. Some people like to secure only the API gateway and keep everything else in a private cloud. Some people like to secure each services. I have other video where you can learn how to add security to your services based on your security requirement. Okay, now let's start coding. For that, I'll initially go to start.spring.io. From here, I'll select Gradle project, language Kotlin, use the latest version of the Spring. And for dependency, I'm gonna choose web, config client, and discovery client. So initially, I will not use those. I'll show along the way where and how to use those. Let's change the group name and project name. generate the project, open it up with your favorite IDE. I will use IntelliJ. But you can definitely use any other IDE of your choice. Let's go into the code. I'll create a simple REST controller, book REST controller, and add two simple method for getting list of books, individual book. Let's add the DTO and the books. And that's my basic Spring application. I'll do the same for order service. In here also I will add a simple controller. This will be not doing much, just getting some request in this URL and just printing out the book ID with this message. Now let's go to our slides, and according to our discussion, initially we'll set up the config server to centralize our configuration, and discovery server where it can keep track of all the running services. Currently we have one, but we'll increase it more along the way. First, let's set up the config server. And add config server. And that's all I need. Open it up like before. We will not have much code in here, just an annotation, enable config server. And in the application properties, let's first change it to application YML and add these properties. So it says where other services are gonna get their configuration. So this is the URL and where it is going to run. So let's go into this URL and see what is available there. So it's a basic repository with service name and their respective properties. So let's look into some. So it is not much, just defining the server port, but you can definitely add more according to your need. Now let's add the discovery server. So from that I need to add the Eureka and change the artifact name to service discovery server. Generate the project. Open it like before. Add one simple annotation to the application. Enable Eureka server. And in the application properties, it's just to be changed to application YML. Here we'll put our application name, service discovery server, and where to get the configuration from the configuration server where we are going to run it on port 8888. So let's first run that. Now let's run the discovery server. So this IP address is the IP address of my machine. can see. Okay, I forgot to add one library, I think, the config client. So let's add that. Refresh the project and restart the application. Okay, now our Eureka is running. Go to this localhost 8761, then you get the Eureka dashboard. And currently there is no instance because we did not enable the config server or discovery client in our microservices. So now let's add that. First, let's add it to book service. First, change it to YML. Then put the configuration, book service. Run the application. Let's do the similar thing to our order service. Change it to YML. Change it to order. And we also need to add the enable discovery client. Run the application. Let's add the annotation on the book service. And run the application. Okay, let's go into our Eureka dashboard. Now, if we refresh, we see order service already here. And if we refresh again a couple of times, the book service will also show once it is running. So let's refresh. So we have both order service and book service here. So let's go to the books, see all the books. And we can go to individual book by going to its ID. And in the order service, slash some ID. So it's running as expected. Next, let's add API gateway to add the load balancing and circuit breaker and rate limiting. For that, let's go to start.spring.io. Add the artifact API gateway. Here we're going to use the discovery client, config client, gateway, web. So these are the main things. Other things I'm going to add now, those will be used later. I'm just adding it at first. Among those are Zipkin, Sleuth, Prometheus, actuator, Redis, circuit breaker with resilience 4J. Alright, let's generate the project and open it with where you want to put it. Now open with your IDE. Let's add the config server information first. Let's change it to YML. To add the config server information, so it's the API gateway and the config server URL. Let's go into the code and change first, make it enable discovery client. Next, we are going to add a bean which will communicate with the downstream services, in our case book service, with a load balancer. So let's see how we can do that. inside we're gonna define all our routes. So let's add our first route, which is books. So this is the ID of the route. Here we're going to set the path to our downstream service, which is books. And the URL. So rather than using this IP and this port, we are going to use the service name that is mentioned in our Eureka Discovery service, which is this book service. So let's add that. But before adding that, we'll put this LB slash book service, and that's it. Now this LB is going to do the load balancing for us. Now this LB will load balance for us with all available book services. So currently, as you can see, we have only one, but we'll add more soon. Now let's run the application. And in here, this is API Gateway's application name, and in our config server, we mentioned the API Gateway configuration over here, which is it is going to run on port 9999 for now. Now let's go to there. This localhost port 9999/books. We get the information from our book service. So currently we have only one book service. So to simulate other instances, I'm going to use Docker. I'm going to run sudo docker run this image. So for me, it will do instantly because I already have downloaded the image. First, we need the IP address of the container with hostname -i. So this is our IP address. Now I also need the container ID. It's sudo docker ps. This is our container ID. Now to copy our book service, let's go into our book service. And before putting it in the Docker, we need to add some configuration over here, which is this. So it will be identified with IP address, and here we have to put our Docker IP address. So let's grab that. So normally when we are running this with Discovery enable Discovery client, it will look for the Eureka in localhost. That's why we need to say that it's not in the localhost, it's in this particular IP, and the application is running here, and we'll prefer the IP address over here. And before running it, I'm gonna make this change also, so that we get result from both places. We can visualize it. All right, we have everything there. Now we're not going to run it. We're just going to create a jar from it and copy it in our Docker container. First we're going to make the jar with book jar. Here we have created the book jar. Now let's go to the terminal and to this directory and copy it in our container. Change the container ID. Okay, it will cd and the ls. We see our book service jar, and just simply run it with java -jar. Okay, so there is a problem. This needs to be actually here. I put a space. The jar is violated. Now let's do the same from our terminal and run it again. Okay, now it's running properly. And if you go to our browser and go to the discovery server, Eureka server, currently as you can see in the availability zone we have one, because previously we had one instance running. Now if we refresh, we'll see two, because we are running another instance on the Docker. So if we go there and go to this books URL, we'll see this coming as one as we differentiated. And if we go to our local host, then we'll see this two on the name after the name. Okay, so in the both places we are running it. Now let's do the same from our API gateway. So if we now refresh from here, sometimes you will see that we are getting from one, and sometimes we are getting two. So that's load balancing in action. Next, let's say this book service for some reason is unavailable. So in that case, rather than showing like 500 or 503 error to end user, we want to give a empty list in the books endpoint. So this is called a fallback. So let's see now how we can add fallback to our system. So for that, first I'm gonna turn off all our services. Stop that. So don't need this anymore. We can have this. This is also not needed if we are running at localhost, but if we are not running at localhost, then we can keep it and point it to the Eureka server destination. All right. Now let's go to the API gateway and let's add another route similar to the books route. This can be called as book list, and URL paths can be book list, and we need to add filter. Set path to our downstream service, which our case books. Add the circuit breaker. Set the fallback URI. So fallback to this empty list. So currently we do not have the empty list REST endpoint. So let's add that in here. So if book service is not available, it will go to this place and it's just gonna return an empty list. So let's see how it works. Let's restart our API gateway. Okay, our API gateway is running. Now if we go to the browser and go to this URL, change the URL to books list, and in here we have to change the forward to single slash and restart the application. Now in here, if we go to this books list, rather than seeing this 503, if we refresh, now we'll see this empty list. So that's circuit breaker in action. Next, let's say this book service is not very high performant and there are a lot of requests coming, but we want to rate the amount of requests coming to our book service. Maybe per minute we want 5 requests. This is for a just example. So how we can do this rate limiting in our system. So let's see next how we can add that. So for that, in this filter, we need to add the request rate limiter. And and add to property rate limiter and key resolver. So currently we do not have the configuration for this. Let's add the configuration now. So this key resolver currently applied to all user, but we want to set it for per user. But for that we actually need user information, and for that we also need the Spring Security. But as I have mentioned, I'm not adding Spring Security to our application. But when you add Spring Security to our application, all you need to do is remove this line and uncomment this line. Then this rate limiting will be applied to per user. And in this rate limiter, we are mentioning that every 2 seconds we are only allowing 2 requests. If it is more than that, then the server will return like too many requests. So let's add these 2 bits in our rate limiter. Key resolver. So before running the application, we actually need to run the book service. And then add Redis information, and finally run the Redis on our system. Now we can run the server. Okay, so server is running, and if we go up here, we are seeing the result. But if we refresh, sometime this we are getting this 429. So let's see what actually happening by going to the developer tools and go to the network tab and select on preserve log and do this refresh couple of times. So sometime we are seeing that we are getting this error. So as we have configured, we are getting this 429 too many requests because it's doing more than 2 requests per second. Alright, so that's rate limiting in action. Now, as discussed on our slide, how to see if all the services are running properly from one service to another service. So for that, initially as mentioned, we are gonna add Zipkin. So to add Zipkin, we already added the Zipkin dependency and the sleuth that we need. So here it is, and the sleuth. So we have the dependency in our API gateway. We need to add all this into other services as well. So let's add those on the book service. Refresh the project, and also in the order service. Refresh the project. And we also want to add another method that goes from book service to order service. So we could have easily done that with REST template, but I want to show you that API gateway load balancing is not exclusive to the API gateway. You can have this API gateway library to any other services. So let's see how we can add that to all the services. First, let's add the API gateway dependency. To our book service. Next, we are going to add the necessary bean to make call from book service to other services with this API gateway jar. Let's import. Next, inject the dependency. Next, let's create an endpoint. Next, let's add the code that goes from book service to order service with this URL and this request. Finally, let's add Zipkin related configuration. So here just mentioning where we are going to run the Zipkin. So we are gonna run locally, and this is our PC's IP address and the port, the default port. And here we are seeing to sample all the requests rather than skipping any request. So let's do the same with the order service. And also the API gateway. Now let's run all the applications. Next, let's run the Zipkin UI. So we can download Zipkin from official Zipkin IO. Here you can go to quick start, and depending on your system, you can get instruction about how to download and run. I already downloaded it, so I'm gonna just run it. Java -zir zipkin.zir. So as mentioned, Zipkin is running on local host this port. So let's go to our browser and go to this URL. And we have the Zipkin UI. Now let's make some request over here. So this is directly going to the book list. So let's forward it to our book service, where it is communicating with the order service with book/order/id /order/some ID. So let's get this ID and put it over here and make the call. So we are getting the call to order service like this, from API gateway to book service to order service in a blink of an eye. Now let's go to the Zipkin UI and run query, and we can see some nice graph. And here, this is the one we just done recently. So if we click on show, we'll see nice waterfall graph that how it is going from one place to another. So as mentioned, it's going from API gateway to book service to order service. And here, if we click on individual bars, we're gonna see where it is going, from where to where, how much time it is taking, which URL it is hitting, which controller it is going to, which method it's going to, what is the IP address and port, and everything will be shown over here. So that's how the distributed tracing works, and how we can visualize it, how our request is going through each steps. Next, we are going to set up Prometheus and Grafana, and as mentioned, for Prometheus and Grafana, we also need actuator. So let's add the actuator. To our book service. And add Prometheus. And in the application YML, you need to expose certain ports. Currently, I'm gonna expose all the ports, but you can definitely add security over here as well, to show which user can see which management endpoint. And with that, I'm going to restart the server. I forgot to refresh. Now let's run again. So after re-importing the Gradle dependency, restarting the server, we get this actuator endpoint. And here we can see the Prometheus endpoint is also there. So you can also go there. So this is the Prometheus endpoint. Now if we go here like books slash so books obviously giving us all the books, and if I go to the this endpoint, this is also giving the information. Now we need to run the Prometheus to view it in a nice manner. So for that we can download the Prometheus from the official Prometheus site. Here you will see all the information how you can download Prometheus. So I already downloaded it. Now let's run it. Okay. So here first we have to define our Prometheus YML. So let's see what's inside Prometheus YML. So here we have to mention these are the necessary part. There are other configuration that can be shown in a separate video. But for this, we initially need this scrape interval, 15 seconds. So it's when I scrape for 15 seconds and evaluate it for 15 seconds, then show it on our Prometheus UI. And we are defining the target, like which service it's gonna communicate to get the metrics. In our case, book service, where actuator Prometheus, what is the URL? So this is the target, the IP address and port. Now let's run Prometheus and go to localhost port 9090. This is the default port for Prometheus. You can obviously change it. And now let's make some request over here. If we refresh and see, go down, okay, we have it in the up, so we can see that we are getting this information, how many times this is running, or what is the rate and everything. So this is showing over here as we are making the request. So if you see, we do some more request. Initially it was 11, now if we refresh it increases. So you can see the same thing on our Prometheus dashboard. So the query is similar as we have seen over there. So you can run this and see with each endpoint how it is getting requests. So here the same result we are going to get 16 times this URL is getting hit, and other URL this time it's this one is getting 8 times hit. It also shows a like a basic graph, but we can use much more advanced graphs and alerts with Grafana. So that's Prometheus. And now let's see how we can see it nicely in Grafana. Okay, now let's run Grafana. So initially you can download Grafana from their official site. So here choose your OS and download it accordingly. And I have already downloaded it. Let me go there. And from here I'm going to run the server with this command. So by default it is running on port 3000. So let's go there. So default username is admin and password is admin. You can obviously change it. So this is how it looks basically. First we need to add the data source. We're going to add Prometheus. So to add the Prometheus we need to go to this Prometheus dashboard and put the Prometheus URL. Of course you can add the authentication information over here if you have. Let's add it and let's go to the dashboard. Currently we do not have anything, but you can have your only your own panels and graphs, but I'm gonna add a graph list which is nicely integrated with Spring Boot, and its ID is 4701. Select the data source and import it. Change it to 5 minutes to see nice graphs available, like uptime, start time, and everything. And in here we can do the same query that we have used in Prometheus to generate a graph. So let's grab that and add our own panel, put the same query and apply it. Now you can see the nice graph over here for last 5 minutes with all queries. Now let's say we want to see the graph of all the requests that is getting as 404. So currently every request is getting success. So to simulate that system, we're going to add a dummy endpoint that is going to spit out 404. So let's add that to our book service. So this is this simple endpoint. So if it comes to this URL and selects book error true, then it will give not found 404. If it is false, then it will go show OK. All right, so let's restart the book service. We don't need to restart API, but we're going to restart it anyway because it takes some time for Eureka to register our available services. That's why we're restarting. Okay, both services are running. Now we just need to go this URL. So if we hit true, we'll get not found. Let's do it over here a couple of times. And it is false. We'll get the status OK as expected. All right, now let's add another one. So first let's see it over here. Let's do the query again. So initially it may not show because it takes 15 minutes to show. Sorry, 15 seconds to show. So it is showing over here 404. 15 seconds is already done. And then we can now query based on the URL or based on the success. So let's query based on the success with this syntax. Now it is showing the query for that particular option only. So that's great. And as mentioned before, you can use the same thing on the Grafana. So let's add another panel and put the query. Change the name to maybe error count and apply it. Alright, we are seeing some requests. Now let's do it a couple of times. It's true. So we're getting 404. Let's do it a couple of times. And after 15 seconds, this will be reflected on our graph. So as you can see, it is showing in our graph. Let's expand it a bit so it's showing properly. Now we want to set an alert. So if it is maybe more than 20, we want to send out alert. So let's see how we can do that. So for that, we are going to go to this alert, create alert, and we are going to define rule how this alert is going to be fired. So it's going to evaluate for 1 minute, check it for 1 minute, then evaluate for another 1 minute, then it will do the firing. Initially it will be in the pending state and then it will be in the firing state, and we want to set the value. So let's set the value to 20. So if it is 20, it will show the alert. All right, so let's save it and apply. Now let's go to this URL and make this call a couple of times. And in the Prometheus, after 15 seconds, we'll see that it is increasing as expected. Now if you wait for 2 minutes, we'll get alert information over here. Initially it will show yellow and then it will go red. So currently, as you can see, it is showing green first because that 2 minutes is not expanded yet, so we'll wait for it. I will forward the video. As you can see, now it's showing yellow. Now if you go to this tab, as you can see, it's in the pending state. So after 1 minute it will go into firing state. So here you can set up more, you can pause the alert, or you can edit the alert to set the alert recipient. So let's go there and see how we can add the recipient. So you can add the recipient over here. So we're not going to add it now. Just wait for another 1 minute to see it in the red. So as you can see, now it's in the red and it's in the firing state. So it's alerting. So currently it is just showing the alert, but if you can configure email sending over here also to send email about this particular alert. So that's Prometheus and Grafana, and that's the end of this video. That's all I wanted you to see in this video, how you can set up your microservice and monitor it and maintain it. So that's all. If you have any question about the video, feel free to ask your question in the comment below. I will upload the code of this video in GitHub and post the link on the video description. So thank you for watching. Have a nice day. Bye bye.